so we'll start in a minute and check out your notes. Hello. Hi. How you doing? Hello. How you doing? Okay, so we'll go ahead and get started. So this week, we're gonna talk about protocols and a little bit of the standards. We'll talk about 802.3, and some of the standards along with TCP/IP packets. We are a little behind, right, due to the holidays, and I was sick 1 week, but we'll be able to catch up towards the end. So for this week, we'll begin with network protocols. So protocols are just gonna be rules, and the industry follow these rules to build or develop equipment, like your wireless routers, your Ethernet adapter, or even Bluetooth devices. So in this industry, IT and cybersecurity, you must remember protocols and their ports, right? I can't emphasize that enough. So just like you, when I first got started, everything is mumbo jumbo and it's very confusing, right? A lot of acronyms, aka just like letters. So you would see acronyms, but we must remember, right? Whatever it takes, maybe you can make flashcards or create notes, but memorization of protocols and using it and understanding it is going to help you in the long run, especially in IT, network administration, and cybersecurity, because when you assess a network, you have to understand what services it's running. And every single service, from remote desktop to voice over IP, uses some form of protocols, right? So we must remember, okay? So we need to define what protocols will be, and you will see some of that on certifications. So network protocols are just a set of rules, and the industry established these rules so that way all the manufacturer can utilize, right, these rules to build equipment. So that way you can have different brands and it will work with across the world, right? So for question 1, it asks you, what are network protocols? And we established that on page 1, so you can click that from the notes or summarize it. And how are network protocols used to establish system communication? So we said that network protocols are rules that the system uses for formatting and processing data. So it could be a protocol to bring your data into the network and outside the network. That's considered routable protocol. It's kind of like a vehicle to bring you into town and leaving town, right? Routable protocol allows you to go in and out of the network. And some protocols are not routable. Think of it that you can only stay within the town or the city. Those services is within the network, right? So these protocols enable the system to communicate with each other, regardless of the hardware and the software. So I can use Windows PC and be able to connect to a wireless network. And my wireless router is not necessarily the same brand from the manufacturer. Or I can use an Apple computer to connect to the wireless network. So it allows us to have a diverse environment of systems, hardware and software wise, right? Because communication system can be in many different forms. It could be a user system, it could be a telephone that is connected in the network and have an IP address, right? It could be a smart device. It could be an autonomous system. So you have a lot of different hardware at work to communicate, and they would send traffic back and forth. In the next section of your notes, it talks about NetBIOS, right? I know some of you are writing down NetBEUI, but let me talk about NetBIOS and then we'll understand a little bit more about NetBEUI. So here it talks about non-routable and routable protocol, right? So NetBIOS exists because back in the day, our system can only see one another by name. It's like how you know your friends by name, right? And that telephone number belongs to your friend if you save it to your phone book on your smartphone. And so when you search for it, you search by your friend's name and it's going to show that number, right? Nowadays, we don't use name that often, right? So we can still see the host name, but we use numbers, IP addresses in different versions. And so that allows us to streamline on how the system sees one another. But the legacy system see each other by names. And that's limited to 255 characters, right? Because of the encoding for this particular set of rules. So NetBIOS extended user interface is known as NetBEUI. This is a transport protocol that was created by IBM. And it was made for Microsoft system, aka Windows and DOS back then, right? So this is way before for most of you who you were not born yet, right? This is long ago. So it was a simple protocol to allow the system to communicate. But NetBEUI uses MAC address. So the MAC address is a physical address of the system. Why do we say that? It's ingrained onto your network adapter, whether it's wireless or wired. So when you connect your Ethernet adapter, that adapter has a number that is assigned, right, a physical address to that system, to that vendor. So if I buy a Dell computer, right, Dell have obtained an address from an address pool, and the MAC address is then stored onto that board, and then it is built onto that computer. Now, the MAC address is functioning at OSI layer 2. We'll talk a little bit more about OSI and extension later on. But the switch, we talked about this during for our week 1 lecture, right? The switch uses the MAC address to locate the physical system. So NetBEUI is a way that we would associate the physical address, like your home address, to a resident name. Let's say that your parents or yourself own a house, right? And we would associate that as the street address number to, let's say, the Lopez resident, or the Gonzalez resident, or the Johnson resident. So it is associated with that physical system on that street, right? That home on that street, on that segment of the network. Okay, another thing that you need to remember is the port number. When you perform security analysis, the report is going to show the port value, like TCP 80. So when I teach malware forensic this last week, right, to my forensic class, and when they scan the system and it showed TCP/80, and some of the students, they haven't taken the network class or the computer classes, they would ask me, what does this mean, right? So that value just represents that particular protocol. Think of it as an assigned value for that connection, whether it's logical or it's physical, right? And some of them are TCP or UDP, and we'll touch on that, okay? Now, because it is transport related, what you're gonna see is a lot of the session that you are establishing in communication is happening in the transport level. Okay. So this is where data is transmitted. So in an attack phase, when we're looking at transport, that's where payload gets set. Right? So when you're looking at the network environment, there are certain levels that we can actually see, credentials, data, right? Things that are being passed back and forth between systems. If it is not encrypted, sometimes that can be transparent, okay? So datagram mode. So in the next question for number 2, so the benefits of using NetBEUI in an older network is it is efficient, it's simple, that means it requires less resources to route packets, to bring traffic into the network and outside the network. So the major advantages of NetBEUI is that it is simple to install and configure. Because in the legacy system, when you're looking at systems from the 90s, before most of you weren't even born yet, right? Or even late 80s, we don't have a lot of the complex type of configuration that what we see today, right? I might be able to do a peer-to-peer connection, one computer to the next computer. Or I might be able to connect outside of the network using NetBEUI so that way it can transport my data back and forth. But connection back then was very slow. We were using analog signal, and analog is not digital like what you see today. Digital signals are 0 and 1, right? On or off. So the frequency in that, it would go up for 1, and it drops down to 0 for 0, right? Just like how you turn off your light, everything is completely dark, and then turn on the electrical signal, you would receive. But in analog, when we convert things from analog to digital, like sound, like when you talk on your phone, all of your voice data gets converted to digital signal, right? You guys know the process, you know what it's called? It's called encapsulation. So when you talk on your phone, or even when you record a voice message and in text and then send it, right? Or when you instruct your smartphone, right? I can text and drive by doing voice text. Your system converted that signal, the analog signal, into digital, package it, and then that gets sent into T-Mobile, Verizon, AT&T, whatever your subscriber is, right? Through their cell tower, that means through their main switches in the network, gets to the destination, whether it's here in the United States or international, wherever that is, right? So it routes all the way to the destination network, okay? And then when it gets to the destination system, that gets converted back into sound. And this has to be done in microseconds, in nanoseconds, right? So your network has to be fast and it has to have accuracy. So advantages of NetBEUI is that it's easy to install, it's easy to configure. So that way it is very adaptable to the network for the services. So in the following section, it gives you the session mode, and you can click that from the notes so you can summarize it. If you want to type it, you can. So the difference between the session mode and the datagram mode in NetBIOS is that Session mode, it requires connection. That means that it has to establish the connection. If the connection is not established, session doesn't occur. Okay. And you do see some of this in the later protocol like TCP. TCP has an acknowledgement that two systems are successfully connected in order to establish any kind of transfer. So whenever that you see connection oriented, it requires the connectivity. And you can monitor for error in transmission, so there's some reliability. And we do see some of this technology getting carried to TCP as well. And so when we run into error, it's going to retransmit. And this is important, that what you see in the switching network today is that when I send data, if it doesn't get to the destination, it would notify the system that's sending. Otherwise, we're going to have a lot of data loss. There's no reliability in the network. Imagine if you send a text. If it gets there, it gets there. If it doesn't, it doesn't, right? And you wait, that can get very frustrating. So we want to make sure communication systems have some kind of accuracy, right? Percentage and also reliability. And then your datagram mode, this is connectionless. So it doesn't need to have a session. Hello. And this is for broadcast. So a lot of the connectionless protocol is used to send to all. So whenever that you hear the term broadcast, it's like radio, right? Whether you turn the radio on or not, it doesn't really matter. The radio station, they still broadcast. Night and day, right? Like 5 a.m. in the morning, 6 p.m. or 8 p.m. or 8:30 when you leave class. You turn on the radio, you hear it, you turn it off, they still broadcast. So a broadcast system is a system that sends to all. And sometimes it doesn't need to confirm whether the other one's receiving or not. So it does not detect error in the datagram mode for NetBIOS. And that means that the application itself has to be responsible for error detection. So when do I choose which mode? Well, it really depends on the need of the service for using this particular protocol, right? And you do see that the system is sometimes it's capable of doing this and that, right? And then, so you as a professional has to decide or configure what the system should be, how it handles the data, because the type of communication that you need to establish. So now, when you look into IT work and cybersecurity work, you do see a lot of things like ability to monitor TCP/IP local area network, right? I mentioned that last time. Asset, right? Systems, or be able to configure a system or work with TCP/IP network. So our network today relies on transmission control protocol, which is TCP, and internet protocol. Internet protocol is purely for addressing. And the address is used for routing. Think of it like the license plate on your car, right? You're able to drive your vehicle and your car is identified by your license plate. The IP address is used to really identify which system is communicating, and it uses IP to locate that system. Just like how we use license plate to locate cars. Transmission control protocol, on the other hand, make sure things get there when it needs to get there. So it's kind of like the delivery person that requires you to sign for the package. So that means that, you know, it tells you, hey, you have a delivery. Are you gonna be available? And you say, yes. I'm gonna be here between 3 and 5. And they're gonna say, okay, I'll come over and drop off the package, not you, because your signature is required. So CPCP requires that the two system needs to establish that communication. Are you available to receive? Yes, right? The acknowledgement needs to be there. So one of the common things that you use every day that piggybacks on TCP is your website. HTTPS. The web server confirms, right? So when you connect to a website, that happens back and forth. I'm communicating with that domain, google.com or youtube.com. It confirms and says, I'm ready to serve you, right? And then, are you ready to receive? And your system says, give me the page. And that's what you load on your page, right? The YouTube page, the Google page, Instagram page, whatever it is, right? So your web application, your web server, it utilizes TCP in the back that way. Now, because it's able to track, right? If things don't get sent properly, it's able to resend or reroute. So sometimes one path might take really long, right? Just like how you drive in school and you see traffic and you're like, oh, I can exit here and take the detour and jump on that street and be able to get there. So autonomous routing system in the world, across the world, right, does this. It has capability to assess based on numerical value and say, okay, we will send this traffic this way, and it still gets to Google in LA or Google data center somewhere else in the world. So when you visit, let's say another country, and you type in google.com, right? Your system is set English United States because the zone that you set for that system, but it's not necessarily serving from Google from LA data center. Right? It could be another server for that particular domain. So TCP and TCP/IP is usually just, you know, reliability and routing. In summary. And so whether you're using a Windows system, a system that's running Linux or old Unix, there's still some of them are around, right? And then your Mac or your iOS, it would work because even if your hardware and software is different, the protocols is standardized across the world, across all the vendors. Any questions? I know this is a lot of information. This particular certification just requires a lot of detail. Network Plus is a little bit different than some of the other certifications. So the more that you're exposed to terminology and understanding it, it's going to help you in the long run. Okay, so I briefly talked about routable protocol and non-routable protocol. So the analogy is that, let's say that a packet is a bus, like your bus that you get on and to take you from point A to point B, or a car, right? A routable protocol is a car that's able to go in and out of town, across state to another city. Where a non-routable protocol can only drive within that city and cannot leave. Hello? So by definition, we use packets. And packets is just a logical aspect of what your communication system send back and forth. So what's in the packet? Just like a shipping box, it has the header which contains who's sending and who's receiving. like how you're shipping a package, you put a label on it, where it's coming from and where it's going to. So with that, we have a source address, an IP address, a destination IP address, and we'll do a little bit of wireless, Wireshark later on. So the router, it uses that information. It's going to say, hey, I'm going to route it to this network, right? To Google domain. So it's kind of like the car is going to say, like if you get into your car and you say, I'm going to leave town. I'm going to go to San Francisco, right? So you have a destination, an address in San Francisco where you're going to head to. Eventually, we'll have autonomous car. It's going to take us there and take us back, right? And then the non-routable protocol, it's not able to send the packets to the router because remember, your router is a vehicle that brings the traffic into the network and outside the network, right? It is your gateway to the world. Just like how when you leave your house, you have to go through the gate, let's say. So in order to get into another network, you have to go through the gateway, which is the router. So the non-routable protocol cannot be received by the router. The router does not accept those protocols. Whereas the other protocol, the routable protocol, can work with the routers. So, any questions? Okay, so for quiz and exam for this class, make sure we know the difference with these. And I will ask questions about protocols and ports because certifications they do, right? You will see that on practice test and also certification exam. So you can search online the common port numbers. I know some of you already know this because you've learned this also in CIS 25, 27. We repeat some of these things until it sticks, right? So we're going to go through the next part, which covers the protocols and the port numbers. So for 6, you're looking at the description of the type of services that you need, and you have to know the protocol. So if I'm transferring file between two computers across the IP network, but it is non-encrypted, right? And there are still tons of them out there. There are servers that provide you files, like Mozilla, that uses FTP. Most of them uses secure FTP or SFTP now. But whenever that you use FTP, file transfer protocol, you're using TCP port 20 and 21. So secure file transfer protocol uses the following number because it also is used for SSH, which is port 22. And SSH uses key for encryption. So when you see secure file transfer protocol, it piggybacks onto SSH, which is the following port 22. That's how I remember it, right? 2021 is FTP, and then right after that is secure file transfer protocol because it uses SSH, and SSH uses port 22. So if I'm connecting to a file server that uses FTP, my system is communicating using port 20 and 21. So this is just a value that is logically given to that communication for that protocol. Then if I'm using SMTP, which is Simple Mail Transfer Protocol, And this is when you're using a server for email delivery in the network, like rccd.edu. When you're logging on, right, you have a server which uses Exchange. But the mail server, its job is to do what? To keep things for all the user inbox and outbox and transport the email to other email servers and then eventually to the destination. So when you're sending an email, there are many different servers in between, right? Not just one to the next. So you're using Gmail, even Google server, there are multiple servers within the Gmail area. And then when it gets to the destination, it has to cross over to other servers. So when you're setting up for a simple mail transfer protocol, you can configure this to your email accounts also. It uses port 25. And that's TCP. So whenever that you see TCP, remember what I said? Reliability, right? In communication. Which takes a little bit longer time. So imagine that your UPS delivery person just comes and drop it off, the package off your door and drives off, right? That's a lot quicker than your UPS delivery person comes, knock on your door, wait for you to come, make sure you sign, right? And if you're not there, come back and, leave you a message, and then he has to come, or she has to come back and get you to sign, right? So TCP requires a little bit more time, so there's like a latency in the process, but you have secure delivery. Let me move this down for the next one. And all of this information, you can find that on my notes document. So, you're typing away, check out the notes, and then you can summarize it. But I can scroll back up at the end if you're missing something. Okay. Then if we're using webmail servers to access the email, the old protocol that's been there, it's called the Post Office Protocol, or POP version 3. And that uses port 110. So if I'm the attacker and I'm scanning your network, which is possible, it happens all the time, right? I'm gonna look for all the activities, all the systems that's talking on your wireless network or your wired network. A lot of times my results are gonna be showing what port is being used for communication. A lot of time you're gonna see 443, that's HTTPS, right? A lot of people are visiting secure domain. Sometimes you would see other services, like mail services. So if you see 110 pop up, you're gonna know that it's POP 3, POP version 3. And then if you see 53, that's DNS. So we have to get used to remembering these numbers, okay? And then when you have client system downloading or searching email using headers, when you're searching for certain email, I do that all the time because I'm not going to comb through my inbox. It might have thousands of pieces of mail. If I'm just searching for a type of keyword or a subject, right? Subject line goes into the email header. Or if I might search for a sender, let's say that I'm looking for RCCD, like that sent me an email. So with that, we would use IMAP, and that uses port 143, TCP. And this is very popular now because of remote work, or in your industry, that most of you are in IT and security. We can remote into a system by directly connecting to that system. We can take over their desktop to install things, right? One of my former students, he worked for an IT service company and he has clients that he worked with. And he has 24 hours, usually to look for malware and different things on their system. A lot of times their IT people might not even detect it, right? So he has to go in and install the patches and all the things that he needs, right? And the company gets paid and they pay him. So when you're using Windows computer that's connecting to another system, remotely, right? You're using RDP, remote desktop, and that uses port 3389. Now RDP, when you enable that, right, the other system has to acknowledge the connection. And then you can also set the amount of time that you can connect to that desktop. So I can use RDP using my laptop connected to another computer at home or at work, right? But in most network, in order to connect, you have to get through the firewall, which is like the boundary protector to make sure that it screens what's coming in and what's leaving. So remember the RDP uses 3389. Now, can administrator use another value? Sure, right? But by default, these are the common port values. That's what you see. A lot of the time we don't reconfigure hundreds of systems to have, there are certain server that runs the same service, but using a different value, right? Some administrator, they'll use a higher number so that way it's not easy to detect when someone's scanning. So you can do that as well. So these are the common port numbers. And so when you're logging in to pay your bills or, when you're using HTTPS, click on login to an account. In the back, when you input your correct password and it's loading your session, so let's say I'm checking my bank account, right? I'm accessing my data securely on the web. So it uses TLS and SSL. Secure socket layer mostly transition to TLS. And they have different version in each, the earlier version have flaws. But when you scan and you see those port value, you would know that it is a secured session for payload or for data transmission. So TCP port 995 and 465. So when you're authenticating and you're accessing your account, and you're retrieving data in that account, like your statement, right? Loans, or even games. For G, when we're constructing or deconstructing multimedia communication session, like voice, video call, video conferencing, streaming, instant messaging, online game, this is called SIP, S-I-P. So it uses TCP and UDP. The reason why UDP is integrated is because it's fast, but it doesn't have to be reliable. So your streaming devices often use UDP. So when you're listening to podcasts, watching online video, when you're playing games, likely that you use UDP protocol. And UDP, right, it opens when it gets there. TCP, it waits for everything to arrive and then open. So my analogy is this. Let's say that you have to send computer parts to your friend and your friend is building a computer. With TCP, all the packages have to get there for all the computer parts, and then it assembles the whole computer and it's presented. It says, here, look, here's the whole entire PC. But UDP, right? UDP will just, if the case arrives, it would put the case there. If the motherboard arrived before the case, it presents the motherboard. So this is why when you're clicking on a video And it's still buffering, right? Because data is still arriving and it's just opening as it arrives. Where TCP, everything has to be in its entirety and then it opens, right? So it is a little slower. So UDP is less reliable, but it is faster, okay? So with that, you would see what's SIP. So when you're using like Zoom and, applications that piggyback on these, because it does voice, video conferencing and all of that, you see SIP is being used. So this is really important for network management and network administration, and even in security side, right? So, and I teach a class, basically it's CIS41D, it's the last in the analyst certificate. And it's really looking at like management strategies for enterprises and integrating security solutions for that, right? So that's really made for like consultant. So SNMP is very important in that area because in an enterprise environment, you have millions of devices, okay? Just imagine corporate world, like your Walmart, your Costco, you have locations everywhere and hundreds of thousands of systems. I'm not going to go and do inventory for all of them, right? In the network environment, that can take a lot of time, right? Even if you have a lot of people. So SNMP allows you to gather the information by pinging those systems or by seeing if those systems are connected. Because a lot of times we just send signal to the system, who's alive, who's on, right? And it sends back. So it's a good way to really see if your system is connecting and it's healthy. And, but the downside of this is somebody can use that to also gather the information from your system. So it's, we do things to streamline and efficiency, but then also someone else can do that to take advantage of your network, right? So you're always looking at services on both sides. So SNMP uses UDP 161. It doesn't have to be TCP. We can use UDP to do this. You can write a script with this, but most of your network appliances and your security appliances has this capability. So you can configure this, to see who's connecting. So let's say if I can check for all the routers, right? Making sure that it's reporting back to my administration system. I can check also for all the client desktop. So it's a good way to manage your network through this service. It pulled the devices. Who's on? Who's off? And then when we do time saving, when you roll back the clock and you roll forward, right? We're about to do that soon. Or when you are going into a different time zone, connecting to that network, you don't have to make manual adjustment anymore, right? Your system is connecting to the switch which connects to the main switch of that service provider. It uses network time protocol, and that uses UDP port 123. And if some of you took my class for ethical hacking, you already know that NTP can be piggybacked for DOS or distributed denial of service, because I can broadcast to all the servers and saying, keep updating time, and all the systems are all busy updating time, then I can slow them down that way too. So a lot of these services can be used for good or bad, right? And then we can have a system that assign addresses, like IP addresses. These are private IP addresses, internal. So before the router inside your network, private IP, right? When it leaves the router, public IP. So at home, your router does this. Your wireless router, its job, its role is also the DHCP system or server, And so when you're connecting, you're able to connect to it to get the internet access, but because it gives you an IP address. So it uses UDP port 67 and 68. That's it. Okay. I didn't list all of them, but make sure we remember, like DNS, that's very important. DHCP, that's important. These are the common services in the network. So when we are managing the health of the network, we want to see what's on and what's not. We look at these ports and the systems that's using these values or these services or working with these services. Okay. Okay, so I put down additional details for a lot of that, you know, your routing, your protocols. So you can read through that. See, SFTP, SSH, and then your TFTP, it uses 69. Another one that you should remember is ICMP. Who knows what that's for? Yes. Yes, to ping. So when does that happen, right? So let's say if we do command prompt like this, you can try this. So if you type CMD on your search bar for your desktop, it opens up your Windows command prompt, and then you can do a ping space and 127.0.0.1. So when I do this, we're doing a loopback address, right? A loopback address is used to find the system itself. It's kind of like, I check to see if myself is alive, right? The system, we can use the loopback address to see if itself is connected, because it sees itself as part of an entity or an object in the network, right? So, but we can also use its actual IP address. So we can do IP config like this. It's going to give you the brief value. So I'm connected to RCCD network. It shows my IP address there. You see that 10.111, right? And then the subnet mask is kind of like its zip code. So it narrows down what segment of the network, and then the default gateway is the router for this side of the network. We're on the darknet at RCCD, so it's slightly different than the other system, or on the wireless side. So when you look at that, depending on which segment you're searching for, so let's see. And then if you do IP config space last all like this, it gives you more details. So earlier I talked about the physical address, right? You see the MAC address here. And then my IP version 6. So we also get the router, which is your default gateway. Here's the server that we just talked about, DHCP, right? That's the system that gives out the IP address. And then the DNS, which is the domain name server, like rccd.edu. Okay. So when you're troubleshooting, sometimes you have to learn how to use command prompt or command line to look for information like that to see if it is connecting. Okay, so please read the notes for more information, right? So Secure Shell is another important one. We use Secure Shell to remotely connect to a system for configuration, let's say. right? Some of you have set up your Raspberry Pi, and whenever that you connect your Raspberry Pi to another system, like let's say your computer, so that way you can program it, you would use, SSH. Um, and then HTTP, I think the majority of our websites now don't use port 80 anymore. Whenever that you see port 80, that's not secure, right? And then we would use HTTPS. So whenever you type in the URL HTTPS, that's port 443. I do see 444 on some networks, so often that you see 443 and 444. So when you scan a network, you see this pop up, you know that they're using HTTPS. And then this is for LDAP. This is what you use. So when you type in your username and password, when you first sit down on your computer, right? A server so they have an Active Directory role that's tied with the DNS. Validate your authentication, and it gives you a security token which loads what you're allowed to do on the network, right? Like let's say that I cannot install an application on these computer, right? It has that in the security token. So LDAP is used for directory, which keeps track of user, computers, groups, systems, organizational units, so much more. Okay. Okay, make sure we know DNS, port 53, both TCP and UDP. That's common as well. Okay, let's talk about OSI layers. This is crucial, whether you're taking Cisco certification or network certification, Network Plus. Okay, we'll start with the layer 1, physical. This is cable communication, signal on the wire, right? When we're making the cable today, so when I take the cable and plug it into my Ethernet adapter, or even wireless signal that sends back and forth, that's the physical. So when you troubleshooting a network, someone calling that, you know what, I don't have internet. You would start with what? Is the cable connected? Right? Is your adapter on? Are you able to see wireless networks, right? That's the physical. We start with troubleshooting with the OSI. Then in the second part, the second layer is your data link. This is where the switch is working. Okay, so it uses LLC, logical link control, and media access control, your MAC address. You see that? MAC stands for media access control. This determines the physical address of the system. This is how it narrows down on where your system is in the segment. And it also corrects errors. So whenever that you are submitting data to the switch, right? So when I'm connecting to the switch has a table. It keeps a list of the systems that are connecting. And sometimes the table goes stale. So we can take a look at the, so the system, it updates it. So that way, if I'm connecting the switch again, it doesn't have to reestablish that connection. The router does the same thing. Okay. So it allows you to connect to the segment, and it narrows down which system by the MAC address. Then router is layer 3. And this uses IP address to move data. Transport is layer 4. Okay, many protocols uses this, right? So if I'm using encryption, who knows which layer it's working on? Anybody? Is it I'm sorry, Brandon. Say it again. Layer 4. Now, in the case if you're using, let's say, email encryption, right? It uses the top few layers. Because in email, I have to access the application, but pretty good privacy. Let's say I'm using PGP, it needs to encrypt, right? Or when I decrypt, it still decrypts and present the data. So it's working with the last few layers. Now, so when you're looking at like the encryption application, you have to looking at like what it's doing. Yeah, but layer 4 is transport. So it's end-to-end data transport service for the connection. So host and destination and internetwork. There are other protocols. So make sure we know protocols to the layer, right? You can see many table and diagram on the web. That's going to be helpful. So that way you can visualize it. Okay. Session is when the server, right, or the system serves an organized communication. So it goes one way only is a simplex, a half duplex, or a full duplex. This is both way. A half duplex is, so simplex, it's either send or receive, one way, right? A half duplex, a full duplex is when it sends and receives at the same time, right? A half duplex is half of that. So that means that it can send some and receive some. Okay. So what we have 3 different modes in order to set that up, but in the session, this is how your system, so you saw earlier that there are protocols that operates across these. And then your application layer is interface with the application. So when you opening the browser, right, simply opening the browser, right, it goes through. So when I open up the browser, it goes through all of these. When I type in a URL, right, you're getting, like, let's say youtube.com, it goes through the OSI layer because it has to be connected to some form of network to send the signal, gets routed out to the domain, bring information back, right? And then put the data in its format. So encoding the data from HTML, CSS, whatever, presented your page and put it back into the application. That's what you see. Okay. Many of my former students tell me this. They get this question on the interview for IT or cybersecurity job and they stumble. You should not stumble because we talk about this in many classes. So make sure you know this well. I know it's hard to remember, right? I learned this when I first learned network. I create a little saying on, each of the layer. So people don't need to see purple alligator. So that's how I remember all the layers. Now, if you're looking at TCP model, TCP/IP model, there's only 4 or 3, so they condense it to less, but same aspect. Okay. All right. Let's go through and answer some questions on the OSI. Let me look at the time. Okay. So which layer sends and receives bits? The first layer, right? That goes through wireless or wire. Which layer works with IP addresses? That's the network layer. That's for routing. IP is for routing. MAC is for switching. Which layer is responsible for coding data translation and code formatting? Like encoding, you know how you have UTF-8 or, so when it's doing encoding and data translation, that's presentation. It needs to put the data in the format to present to you, right? And how it presents to you is through the application, which is interfacing the human. So that's layer 6. Easy? I always remember the layer and the device that, the technology that helps me understand it a lot more. Which OSI layer provides interface with the program? Application layer, like the browser, Chrome, right? Firefox. But sometimes you will have other type of application. I'll move these two down to the next page so we can see more. So to get all of the 7 layers, right? People don't need to see purple alligator, physical data link network transport session, right? And then presentation and application. And when you read another network book, they also have saying something about pizza. But we need to remember. So when I troubleshoot, I refer to the OSI model. I start with, is the cable connected or is your wireless connection established? Right, connection to the network. And then if we're connected to the network, that's the router right here. Right? So you can say, you connected, you can try to open your browser and type in a URL. So when that happens, if I type in the URL youtube.com, right? That's through the application, then it does the encoding, there's a session because the server needs to serve the content, transported session, and then, so. Okay. So make sure we remember the 7 layers of the OSI. We're on number 11 of your assignments. Cable, switch, router, right? Transmit data. You can think of it like encryption, session. This can be a lot of different things. Like cookies also happen here. Then you have presentations where it format your data. So when I'm decrypting, right, it happens here. But it needs to be established. Okay, so the next part, we're going to talk about connection-oriented and connection-less oriented. So in this session, connection-oriented, it needs to synchronize and accept. Okay, this acknowledgement that happens between the systems in order to synchronize the data. Otherwise, it cannot sync, right? Does that make sense? So if I have system A and system B, they both have to say, okay, are you ready? I'm ready. Let's exchange data. Let's synchronize. So in the connection-oriented session, the host needs to establish the rules on how the data can be accessed and synchronized before the data can get transferred. Any question? So you can read, earlier we talked about OSI, right? It gives you a little bit of description. So presentation, transport, so you have to have end-to-end connection, your encryption, compression, translation services, encoding, your dialogue control, your framing happens here. And this is Synact. So when you scan a network, let's say you're using Wireshark, and if you guys can try that actually. If you type in Wireshark and you click it, and then you're gonna see your, so now you're gonna start with physical layer, right? We're gonna look at the adapter. So you are going to choose, you are gonna use your killer, your LAN local area network. I'm gonna use the Wi-Fi one because I'm on my laptop. But if you have wireless on your Alienware, you can also click that. So click your adapter that shows the little line, right? And then you're gonna click the fin at the top. So this is a network monitoring application. This is, it's also known as a network sniffer. It sniffs out all the packets, so all the communication that's being exchanged. See, you see the protocol, you see the packets that are coming through, who's sending, who's receiving, right? You see how there's ACK right here? That's acknowledgement. That's confirmation from system saying, hey, I got it. See 443? See all these packets coming through. And this is on I'm on the wireless side. You can look at the, and if you want to pause, you can pause it. Stop. You can look at, and then you can look at the packet. Wireshark is free. C443. Okay. And it tells you how large is that packet. Now, when you see SYN, that means it's synchronizing. A lot of the times we might not see it from that moment in time because some systems already synchronize the data, but if you scan and you see SYN act, you would see that. Yeah, a lot of 443, you see. A lot of HTTPS traffic, mostly. There's encrypted data right here. So anyone can connect to the network, anyone can scan this. So if I'm sitting outside in my car with my laptop and I'm able to connect to your wireless network or on a free Wi-Fi network, right? Is it illegal to scan? Well, it's not truly illegal to scan the public network, but what you're doing with the scan is gonna make it illegal, right? If you are doing something bad with the scan, if I'm using, so yeah, some administrator, they would prevent you from scanning. They can also see who's scanning. So yeah. More to come with that. So we can close it and you don't have to save it. But so this week in my forensic class, we're gonna take a capture like this and we're gonna see where the phishing email comes from, right? We have a capture and then we're gonna look at one of the packets. So we're gonna see where that email comes from and who received that phishing email and spread it all over the world. Um, so you can capture and you can do forensic with it. You can do a lot of investigation. So that's called a reactive approach in security. It's fun, right? This world is very interesting. Okay, so you would see synchronize. So basically the sender said, hey, I'm gonna send you something. And then the receiver said, okay, I'm here to receive. And then it says, okay, now I'm getting ready to send. And then the acknowledgement will be like, okay, go ahead and send, right? And then so the data transfer. This happens with HTTP, HTTPS, with TCP communication. You see that a lot. Okay. So connection oriented handshaking will take place. Okay. Connection less oriented doesn't require that. Okay. So flow control is the next part, which brings us to the next question. So flow control, what is its purpose? It really is a way for the receiver to control the amount of the data that can be sent. Well, you say, well, why can't the sender control that? But your receiver system is a system that's going to be in charge of the data at the end of the day. So it prevents the sending host to do buffer overflow. Because if it sends massive amount of data, then I won't be able to handle it, right? It won't be able to handle it. But that can still happen. And when it happens is because we don't have proper flow control in place. Okay. So denial of service attack happens because there are not proper security measures in place, meaning what? Detection, and also we have to make sure that the traffic is diversified. That means that it gets handled by multiple systems instead of getting flooded by a few systems. Because you're gonna see a massive, it's gonna come in the same source. It's sometime now that they would group it. They would do a group of systems, and then that's how it can go through the intrusion and intrusion prevention system. Because intrusion prevention system, if it's doing its job, when it sees that, let's say, like 5,000 packets is coming through from this IP address, it should block it and drop it right away, right? If it's configured properly. And it's simply a rule. Anything more than 50 packets, block. And then log that IP address so you can go back. And so when you go to a data center, or you're looking at the server monitoring system, you're going to see IP address from, let's say, North Korea, block, right? Attempt, denial of service attack. It shows that, right? So let's say on the application firewall, or even like deep packet filtering, we should be able to see that for security appliance. But ultimately, flow control allows us to make sure that we handle the amount of data or the communication that's needed. Okay. And this is usually a balancing act, because sometimes if we control a lot of this, it slows down network traffic, and we don't want that. So if we open it up, right? So you take a risk in some sense. It really depends on the network design, how it's designed or engineered, and then the type of systems that's incorporated inside that network. So infrastructure really speaks a lot about, you know, your security solutions at the end of the day. Okay, going back to the OSI layer, your data link. Layer 2 is where the switch operates. And for your physical layer, we already know that bit-to-bit signal, right? That will be your network adapter, your network interface card, which is known as NIC, your cable, like Ethernet cable, coaxial cable, your transceivers, repeaters, and hubs. Unlike the switch has the logical link control, which allows it to do error detection. The hub just pass signal, or the repeater repeat signal, right? So the other appliances compared to the switch, it either retransmit signal or it just transfer the signal. So I'm sorry, did you guys still need 13? Any questions? So when you're getting a signal amplifier, which layer is it in? You know, like I hear people say that all the time. Sometimes I go to Best Buy and I stand in the aisles looking for something, and then I hear people debating like, which one should I get? Like I need, let's say that you have to use wireless upstairs and then downstairs is your router, and then it's not getting enough signal and you're getting an amplifier. It's basically a repeater, right? An amplifier takes that signal and increase it so that way it can send it. So it is a repeater ultimately. A lot of times if it's not equipped with the device, if you have an external repeater, it tends to be not that reliable. They vary. Okay, so router operates at layer 3. IP addresses use layer 3, version 4, or version 6. So when you see an L4 switch, a layer 4 switch, right? That switch is able to do transport, network, so the first 4 layer, right? That switch is able to handle switching, routing, and transport. We tend to get layer 4 switch for what? Voice over IP, right? Or, handling other things, but you see layer 4 switch for VoIP a lot. So how does your data transmit across the network? Your data, which is known as payload, is wrapped with protocol information at each layer of the OSI model. So I just talked to my class the other day, and I asked them, why do we need OSI layer when we assess security in the network environment? Right? It's because there's services at each layer. These services impose risks, right? There's potential flaws in the service. So we have to assess it at each layer, from the physical all the way to application. So when we're looking at data, data is wrapped with the protocol information at each layer. From the time that it encapsulate and decapsulate all the way to the time that it's formatted and presented through an application to the user. So when it from 0 and 1s all the way to formatted text as a web page through a browser, right? Almost done. Any question? Just 2 down. Okay, because the next one's kind of big, but you can find this on your notes as well. So let's talk a little bit about data framing. And frame happens in layer 2 in data link. So framing is basically a data unit. Layer 2 handles, so each layer handles a unit differently, right? So in layer two, the data is framed because it's considered, that's like your data unit. And the frame, basically, they're just bits that's used for payload, which is your data. So how does it know? Is it entire data? Which comes before which? Because there will be many different frames. Your data can be, let's say, 10 gigabytes, or it could be a video, 3 megabytes. It can't just frame in one frame, right? So frame would be smaller, like it would chunk it, and it would use a sequence number to check. So when it gets to the next layer, which is network, it becomes a packet, right? At layer two, your data is framed. So from layer one, which is 0 and 1, right? Bit to bit, 0 and 1, into layer two, then your data is being treated as a frame. So with that, it's able to organize which data is which by sequence. But it's part of your data encapsulation. Remember what I said, right? We have to take bits to bits and then put it into a way that the system can treat it as data. So encapsulation allows us to do that in layer two from bits to bit, which is in layer one. And then we need to take it to the network layer so we can send it inside and outside the network. And we need to make it into packets. So the frame is the unit transmission of the data link consists of the link layer header followed by the packet. So that allows us to take that data and incorporate that into the packet. So the frame is then added to the packet header. And so your frame is separated, right? They're not all together. So when you're looking at the layer two, and when you're using Wireshark, you do see some of this. When you click on the frame information, it'll tell you, especially when you're analyzing it at layer two. Now, when we get to the layer three, this is a way that we can transport data is as a packet. So packet transport data into the network and out to other networks, right? We need to bring it inside and outside the network. So in a segment, we know that there would be many packets. You saw that earlier, all of those packets were coming through. And each of them carry one or more Ethernet frames because we said earlier, your data might not just fit into one frame, it might be many frames. So one packet can have many frames. And we will have many packets for that communication, like, you know, downloading a video from a website. Or performing an attack. Like denial of service attack. So packets for routing, framing is specific. But we need the frames to represent data at the layer 2 level. And you can have many frames to a packet, and you can have many packets for that communication event, I should say. Do you have any questions? So the whole point in this is as you're taking the class and you learn more detail about the technology, it's gonna gel, right? Like I tell that to computer science students. Cause they're like, oh, why do, I run a function in a main and I always do this in C++, and then, and as they go along and they're writing different programs and taking different computer science class, and then when they take me for assembly or discrete structure, and they're like, oh, now it starts to make sense, like why the processor does this, right? So the whole point in this is to give you more insight in specific areas you're taking these classes in the program. So that way it makes more sense, right, to deliver a certain security solution. There's no perfect solution, but we want to be comprehensive about, and then we want to be aware about the technology and knowledgeable in that. So your skill sets increase as you do it. Okay, so we're gonna switch here and we're gonna talk about standards, and we'll take a break pretty soon. So let me see, almost done. And yes, we have to remember these IEEE standards like 802.11, 802.3, 802.5. It should come naturally down the line, right? Like whenever you see Ethernet, 802.3. Okay. Whenever you see wireless, 802.11. Okay. Those are the common ones. Okay. You get to some of the other sections. Okay. So here gives you a little bit of an image on how data encapsulation takes place, right? So from the time that we go from bits to bits, and then bits to bits, and then it does the framing, then it prepares. So when you're looking at the logical packet, you see some of this information, like your LLC, your MAC address, then your IP header and TCP header that gets for routing. And then when it transport, it looks at TCP header mostly. And your session, and then applications when your user interface there. So framing is happening here. So when you're looking at the frame, you see the source and the address, but it's instead of the IP address, like the packet, it uses the MAC. Okay. And then how does it know the segment? Well, it comes down to your subnet mask, and then it's gonna go to the port value. So this one gives you a little bit of the protocols here. There's your sequence number right here, and then acknowledgement. So that's how we can see the act. Okay. So this illustration kind of tell you like the layout of your field length and also your headers. And your data is raw data here, right? So when it sends, it doesn't necessarily in the same especially with UDP, it's not gonna be like, 1, 2, 3, 4, 5. It's gonna be like 1, 5, 8, 2, and then it's gonna figure out when it gets there. So, okay, 802.3. This is for Ethernet. Whenever that you use Ethernet, it's 802.3. Okay, we talked a little bit about the 10 base in the last session before the holiday. So 10 before the base means what? The speed, right? And then the base tells you the media, the type of cable. Okay, so when you see base 5, that's a thick net. Base 2, that's a thin net. What are these? Coaxial. Those are the round cable with the needle, right? So the thick net goes 500 meters. The thin net goes 185 meters. Will you need to know this for Network Plus? Yes. Sometimes they ask these questions. Okay. So there's limitation. The farther you are from the source, the more attenuation you have. Attenuation just means that there's degradation in your signal, right? And that could be from interference or just distance-wise, right? That's just the rule. We already established the speed, so 10 megabit per second. That's the max, right? Max rated. So it will be up to that. So back in the day, if I subscribe to cable and it will say, oh, I can download and upload at about up to 10 megabit per second or even 5, right? So that's because of the medium that they use. Why do we still use coaxial? Because it's cheap. And, it's reliable for most part. Then you got the 10 base T, which is the twisted pair cable. This is your Ethernet cable that you're going to make today. That's 100 meters. Remember, 100 meters. Okay, but we cannot go floor to floor, right? We talked about that last time. When you run it through elevator draft, if you go to the second floor, it's likely that you're not going to get most of the signal. So even when we run it through the closet, so we probably ideally, right, in a tall rise, we want to implement in fiber, and fiber should be your backbone anyway too. You're like at home. So I'm guilty, right? At home, I run an Ethernet cable from my first floor to my second floor, but it's home use. But imagine you have that one Ethernet cable for 100 computer on the second floor. You're going to have a huge bottleneck, right? So not good. We want to have a lot of throughput. Okay, 802.5 is your token ring. Older technology, this is used to pass from one system to the next in a round ring manner. But it does do the collision detection, right? CIS40A. So that way there's order in data transmission. So that way they don't always, they don't collide. Then your wireless, 802.11. Okay, so let's answer these. Okay, so Ethernet is defined as IEEE standard 802.3. Whenever you see 802.11 standards, that's going to be your wireless, your Wi-Fi. Wireless. Wi-Fi stands for wireless fidelity. And the B standard was many decades ago, right? We have A, B, N, right? What are we using now? What class are we using now? You're like, I don't care as long as it works with 5G. It's dual band, but which one? AC, right? So, all right. 802.11b is wireless class B here. The maximum rate was 11 megabit per second. That was pretty hot for its day, Like I want to say a lot of people were doing this toward the early 2000s, maybe 90 something, right? Many networks started to adapt to the wireless. It took us a little bit of time. And then transition to G and then N, right? 802.11 standards transfer rate, that's 54 megabit per second. That was an upgrade from B to G. It is backward compatible. So when I upgrade, let's say I buy a new router that is 802.11G, I can still connect my laptop that use an adapter that's 802.11B. So whenever that you see the standards that's changed from one class to the next, what will happen is you have to think about backward compatibility. We cannot just rip out everything on the network or replace everything on the network that's wireless and upgrade to the new standards, right? We want to make sure that we upgrade the major appliances and the old computer and the tablets and everything still works. AC, you know, it's fairly recent and I think it's going to be here for a while. And there are other classes in between, but you do see that, you know, there's research that goes to some of them. And some of them are faster, some of them are slower, right? But remember, when you're using 5G, you cannot go long distance. Whenever it's higher frequency, you are in shorter distance. Most of your appliances use 2.4 gigahertz, right? So if you're on 2.4, you're able to go longer distance because it's lower frequency and it's able to transfer more, right? This ties back to physics and other things, but just know that the higher the G, the shorter the distance. Okay. Okay. So here is a table that tells you all of that. So AC is where we're at right now, but you're like, wait, in the 90s, they had 5G? Of course we had 5G for a long time, right? People think 5G is new. But yeah, so the frequency is 5 gigahertz. And A came out when wireless first came out. So that was like, I want to say early 90s, late 80s. I want to say 90s, right? And then the B, so you see that there's different speed and different classification of your 802.11. You got the extension for Japan, and then there's, you know, all of this use radio frequency, right? So it is operating in certain range. And what you would see is that they would classify that range for the frequency with the channel for that wireless class. So I think, did I tell you guys about, I looked into drone signal. So drone uses Zigbee, but most of the time it uses laser, or most of the home drone that you see is this, right? And so radio frequency in that certain range, but it happens that the overlapping ranges also is your mobile and your wireless, right? So this is for collision detection, and then all the history stuff with, so 2.4, right, for B. So here you go. In United States, only 11 channels are configurable. Remember this. Channel 1, 6, and 11 are non-overlapping. 1, 6, and 11. Right? On a 2.4 gigahertz range. So if you are installing access point, let's say in the network, you want to, if you don't want it overlapping channel, you need to make sure that it's on channel 1 or 11. Why am I not in the 6? It's because it's so close, right? So you might have like the bleed into this, but the other channels, right, they are overlapping. So if you want something that's not overlapping, you would be able to, you can do 1 or 11. Now, router out of the box, it would say auto configurable for the channel. If you select 5G, it's a different range in the channel because it's higher in frequency, but the 2.4, you see that those are not overlapping. Okay. You can also have power over the Ethernet and then a lot of the wireless capability. Oh, let's talk about MIMO. So antenna is a big thing for wireless. We know that, right? MIMO stands for multiple input and multiple output. This is going to allow you to have many frames that sent through multiple antennas. Okay, that's important. This is known as spatial multiplexing. Now, you can also use channel bonding after 802.11n. That's a big improvement for us. Okay, this is what we're using now. AC. Okay, remember that. Okay, so this gives you the graphic of all the historical from A through B and G. The book didn't have a lot of these stuff. I think I supplemented some of that, but go through it, look through it carefully so you have a better understanding if you want to read through it. Okay, any question? Okay, good. We're done. So we're going to take a 10-minute break, bathroom break, snack break. Let me check to see if the other door is open. Let me stop the recording.